that it can't buy happiness, and that the love of it is the root of all evil. But most of us seem to be obsessed with earning, saving, and spending it. For better or worse, money is the measure of all things in America. And two agencies work around the clock, satisfying our demand for it. The Bureau of Engraving and Printing produces our paper currency. And the United States Mint, the largest mint in the world, manufactures our coins.
We are the largest mint in large measure because we have the world's largest economy. Many mints worldwide have had to slow their production down. In fact, some have had to shut their production down. We, on the other hand, because of the size of our economy, have had very smooth production capacity.
The U.S. Mint runs production facilities in Denver, San Francisco, and West Point. But for more than 2 centuries, the heart of its operation has been in downtown Philadelphia. You can count on this money-making factory to pump out a staggering 11 billion coins each year.
On an average day, we make over 30 million coins. About half of them are pennies, and the rest are split between nickels, dimes, and quarters.
No parts of the Mint's automated production line are more critical than the dies from which the coins are stamped. Creating them is a meticulous and time-consuming challenge. The process begins with drawings crafted by the Mint staff of sculptor engravers.
Today, we do it all on computers, and every image is drawn separately, scanned into the computer. The lettering and all the text is generated separately, and we can move it around, increase the size, reduce the size, change the size of the image if the image is too large. You know, just kind of tweak it to the point where we never could tweak it before.
The approved drawing is the basis for an oversized model, sculpted first in clay, then plaster. Sculpting and enlargement enables the artists to include a greater degree of fine detail.
This is the reverse of the 2006 Nevada State Quarter. I'm putting in the final touches now, and I'm using a tool now to put some straight edges on some of these rays of the sun. They need a little cleanup after the casting. Sometimes there's little pieces that mar the edge. We have a very thin parameter of relief that we can work on in something like this. This is an 8-inch blank, and I think our maximum relief is around 80 thousandths of an inch, and that's the highest point.
A crucial step ahead requires a significantly harder replica of the plaster model. So workers craft a rubber mold that they can then use to make an epoxy copy.
With the brush, we're trying to be sure we don't trap any air bubbles in the detail on the rubber mold, and we'll leave this sit overnight just at air temperature. It'll be hard to the touch in about 6 hours, and it'll take about 18 hours before it's fully cured, and we can separate it tomorrow morning.
The resulting epoxy model is hard enough to withstand the rigors of this machine. The Janvier reducing lathes first arrived from France in 1906, and they're still going strong. They transfer the contours of the large models with minute precision to the heads of coin-sized steel cylinders.
What's going on here is this stylus is actually riding on the surface of the hard epoxy model. And as it moves in and out, this arm also moves in and out, causing this cutter to move in and out and actually trace the image into the steel. This machine is completely mechanical in that there's no computer assistance at all. It's all done through electrical relays, leather belts, and screws and cone drives.
Transferring the features of the model to what's called the reduction hub takes as long as 12 hours and requires several repetitions. When the hub is ready, it's used to craft the master die. The master die will be a reverse image of the hub, with recessed rather than raised features. This crucial step allows no margin for error.
Any little water will imprint on this, fingerprints will imprint, lint marks, dust, dirt, all will mess this thing up from the get-go.
In the die press, the reduction hub is positioned on top of a steel cylinder with a cone-shaped head. The two are precisely aligned with a centering ring. press descends, flattening the cylinder against the hub. The cylinder's coned end prevents the cylinder from absorbing all the tonnage at one instant and allows its metal to flow in and around the hub's relief. There's still some touch-up work to do, and duplicates for use on the production line will have to be made. But what emerges is the stuff that coins are made of.
And the end result is a brand new master die.
The process of creating a master die may be slow and methodical, but the coin production it empowers blurs by at a lightning pace. It begins with prefabricated metal strips coiled into rolls 1,500 feet long. The coils are fed into a machine that punches out round discs called blanks. The blanks for pennies come ready-made from the mint supplier.
After blanking, all the blanks go through a furnace where they're heat treated to soften the metal. We have hard metal to get good sharp blanks, but then we need to soften the metal to be able to strike our coins.
Next, machines wash the blanks to improve the coin's final appearance. And after other machines dry them, they flow into a device called an upsetting mill. The machine raises a rim around the blank's edge that will be higher than the coin's relief, protecting the design. A horizontal wheel with a grooved edge rotates near a curved section of steel with a corresponding groove. The blank spins into the channel, which grows progressively narrower. When the channel becomes narrower than the blank itself, the blank flattens at its edge.
That raised edge or rimming helps preform the blank so that when it goes into the press and it's actually struck into a coin, we get better fill, better appearance of the overall coin.
Finally, conveyors whisk the blanks to the coining presses, and their close encounter with the master working dies. Each press can stamp out 750 coins per minute.
Our coins are struck using two dies that are installed in the stamping presses. One makes the heads or the obverse, one makes the tails or the reverse. One is stationary and that's called the anvil, one moves and that's called the hammer. The blank comes in between, the one die moves and strikes the blank in between that die and the other die, creating the impression of the coin on both sides at the same time.
To ensure that nothing's gone wrong anywhere on the production line, inspectors scrutinize the newly stamped coins.
It would be an impossible task to inspect each and every coin. What our operators do is they sample ones that are collected in a trap or a reservoir just outside the press. When they're satisfied that it meets our quality standards, they release the trap, and those coins that are made in a similar time period then flow on through the process to be counted and bagged.
Each of the bags into which the counted coins fall weighs roughly 2,000 pounds. Ready for shipment to the Federal Reserve. This efficient production process would have no doubt amazed the founding father, largely responsible for the mint's founding. When Thomas Jefferson became America's first Secretary of State in 1789, the new nation's monetary system floundered in chaos. No unified form of currency existed. The individual colonies circulated a wide variety of bills and coins. And that was only part of the problem.
As the country expanded and we had foreign colonialists coming here from France and Britain and Spain and Portugal and Germany, their currency was oftentimes used as a form of commerce.
And it was a mess because every colony had its own exchange rate. So Jefferson really came to understand how over the long term the country just could not conduct its business, and it could not conduct its economy with this kind of a system. He advocated the creation of a decimal coinage system in the United States and the creation of a mint.
America's first Secretary of the Treasury, Alexander Hamilton, shared Jefferson's passion to reform the nation's currency. But the two political rivals, constantly at odds, disagreed about what form that currency should take.
Hamilton believed in banknotes. Jefferson believed in coinage. So it's not surprising in 1792, when the Mint Act was signed, that coins were placed under the Secretary of State, where Thomas Jefferson was secretary. The first mint was established and produced coins and not notes. And that is important in terms of the history of the country. Notes didn't really start to enter circulation until much later.
The U.S. Mint was erected on the site of an abandoned brewery in Philadelphia, then the nation's capital. Production commenced in 1793.
President Washington lived only a few blocks from the first mint, and it is thought that perhaps Martha Washington donated some of her silver to the Philadelphia mints for some of the first production. While we don't have any documentation on that, we do know that some of the first copper that was used was from Paul Revere's manufacturing company, and it was used in some of the first coins.
In the old days, there were no clay models. The engravers would actually work directly in the steel. This is what they generally looked like. And what they would do is they would transfer the drawing to this round image. They'd use an ink. And then they'd begin cutting and carving, cutting and carving, cutting and carving, shaping and forming, shaping. And this whole process, I mean, you can see, just look at the detail on this. It's just absolutely amazing. It could take up to 6 months.
In our early days, all the coins were made by hand, and they would take the metal and they would form it into strips using a rolling machine to get the desired thickness or gauge. Once they had the strip, each blank was hand punched from that strip to create a blank. And the blank was then taken to a screw press, placed on top of one die, another die would be positioned above it, and the screw press would be cranked down in order to stamp or impress the image into that metal. And in that method, it took them 3 years to make the first 1,000,000 coins for our nation.
The mint's slow pace irritated Congress, as it failed to meet production demands. More tumultuous times lay ahead, especially when a chance discovery in a remote riverbed triggered events destined to rewrite the mint's history. In 1999, the United States Mint gave the quarter a new look. George Washington still adorns the face, but you can never be sure which of the United States might be emblazoned on the reverse. Every 10 weeks until 2008, the Mint will roll out a new quarter honoring a different state in the order that it joined the Union. 140 million Americans are caught up in collecting the coins, and the Mint continues hammering them out by the ton to keep pace with demand. In the early 19th century, the people's demand for federal coinage was no hobby. The economic health of their growing nation hinged on the Mint's ability to power a practical system of exchange. But the Mint's production still lagged. In the 1820s, the nation's first gold rush complicated its coinage predicament. After prospectors struck it rich in the mountains of Georgia and the Carolinas, they had a wealth of gold dust, but no efficient way to convert it to coins.
You could ship it all the way back to Philadelphia, where it was melted into coins and sent back, but this process took some 6 months. So you were forced oftentimes, as a miner or merchant or whatever, to use the gold dust.
A Georgia gunsmith named Templeton Reed had a better idea. He built his own mint, then bought the miner's gold dust and made his own coins.
Under the United States Constitution, only the federal government had the authority to make money. But he was the first of some 40 different individual and private coiners who made coins to feel the need for a medium of exchange in these gold rush areas when the government failed to do so.
In 1838, Congress finally took action, opening mint branches in North Carolina, Georgia, and Louisiana.
It made a lot of sense for the United States government to actually establish mints in those locations. That would be, I think, in some ways, the equivalent of shortening the supply chain, is the terminology that we use today, is going to the source of your metal.
The precedent was set. In 1848, when the cry of gold echoed from California, a similar scenario played itself out. entrepreneurs in San Francisco opened private mints to convert the miners' treasure into coins. 5 years later, the government moved in, absorbed the facilities, and established a branch of the U.S. Mint still in operation today. In the late 1850s, subsequent gold and silver strikes spawned more branches. Nevada's Comstock lode triggered the creation of the Carson City Mint. And the Pikes Peak Gold Rush in Colorado gave rise to the Mint in Denver. In the meantime, the Mint in Philadelphia had moved to a bigger building, and its equipment now hissed with the power of steam. By 1860, it was pumping out 28 million coins every year. As the government-controlled coinage was gaining strength, the nation's paper currency, controlled by the private sector, was flaunting its weaknesses. Confusion reigned as 1,600 different banks were circulating 7,000 varieties of bills.
The further you got away from those issuing banks, they traded at a discount to face value because of the inconvenience of having to go take them back to that bank. And then once you got a certain distance away, they weren't worth anything. No one would accept them because they didn't know what the creditworthiness of that bank was.
You never really knew what the real value of a Tennessee note would be in Virginia. And in fact, you would never know if a Richmond note would be even acceptable in Baltimore. So those kinds of problems really meant that we needed to have a centralized point of issuing currency.
A catastrophic conflict finally compelled change.
In the 1860s, Congress had realized that they needed some way to finance the Civil War. And one of the things they did was to authorize the Secretary of the Treasury to print a paper currency, which was a demand non-interest bearing note. And in fact, it was called a demand note.
The Treasury began production in 1861. Workers operated machinery primitive by today's standards. But the basics of their technique were so sound that they're still being emulated. First, printers applied ink to a metal die. The ink filled the tiny recessed lines and dots of the engraved image, which was carved in reverse. Subsequent steps removed the excess ink from the die's surface.
I'm going to take a piece of what they call crinoline or crinoline, and what you want to do here is just barely go over the surface, and it's going to take the heaviest part of the excess of that ink away.
After covering his hand in talcum powder, the printer then buffed away whatever traces of ink remained.
As you can see, I'm not actually taking the ink out of the engraving, it's just polishing the surface. So if you notice, all of the ink that's left is in the engraving. The rest of it's on my hand.
The inked die was then ready for the press that would print the banknote. The Treasury's earliest models were known as spider presses because of their long radial handles. They employed a method of printing called intaglio.
And intaglio basically means beneath the surface. It is where you press the image into the substrate, in this case the paper.
An intaglio press draws the blank paper, positioned atop the engraving, beneath its drum. This forces the paper into the die's finely recessed lines to absorb the ink. The resulting banknote features a subtle three-dimensional effect. The surface of the note is slightly raised.
If you pass your hand on any object that's intaglio printed, you will be able to feel differences and ridges, and that adds to the distinctiveness of currency.
That trademark feel of American currency is also a product of the specialized paper on which it's printed. And surprisingly, the main ingredient of that paper is something you might be wearing right now. We all know money doesn't grow on trees, but it does sprout from, of all things, blue jeans. discarded scraps from the denim garment manufacturing process are sold by the ton to make the cotton-based paper on which United States currency is printed. This is the facility hungrily buying and stockpiling it. Crane & Company in Dalton, Massachusetts. Since 1879, this family-owned firm has produced all the specialized paper used to make American banknotes.
There's no getting around the fact that the paper in a banknote is much of the mass. It's at least 90% of all the material there. So it's like the crust in a pizza.
Waste cotton comprises about 75% of the material Crane uses to make its banknote paper. The other 25% is waste flax. Paper currency must endure a lot of wear and tear, and paper made from wood pulp couldn't survive the abuse.
The fibers in wood pulp are not as long and not as strong as the fibers in cotton. We have nearly pure, highly crystalline cellulose in cotton, so it's much stronger, more brittle, a rattle in the paper when you move it, a crispness, all those characteristics that make U.S. currency paper so distinct when you feel it.
Achieving that distinctive feel, which counterfeiters find very tricky to duplicate, is the result of a time-honored and painstaking process.
The first job is to remove some of the natural waxes and oils that are associated with the otherwise very pure cotton cellulose fiber. And this and the oils and waxes are generally removed in a pressure cooker, in what we call a rotary boiler.
For 2 hours, 6,000 pounds of cotton in the 15-foot wide boiler cooks in a caustic bath of sodium hydroxide and other chemicals. A conveyor then dumps the steaming shreds into a pulper that breaks down the cotton into smaller fibers. At the same time, water washes away the caustic chemicals still lingering in the material. Another conveyor advances the cotton pulp toward additional washing stages.
This is the final washing stage here. This material will be transferred along this conveyor up into our bleaching stage. We'll take this and we'll make it a whiter material than what it actually is now.
After the bleaching process, we remove the water from the pulp. Not 100% dry, but sufficient so that we can stack it on skids and move it around from one place to another, and that's what we stockpile.
Several of the ensuing steps are secret and can't be filmed because they involve adding critical anti-counterfeiting features. Crane will mix red and blue security fibers into the pulp, which will become randomly distributed throughout the paper. It will embed a security thread denoting the bill's value at a precise position within the note. Crane will also incorporate a watermark that varies by denomination, a faint image mirroring the portrait on the bill. The watermark process begins with a pair of bronze dies used to impress a 3D image on a wire mesh.
You can see here are embossed three-dimensional structures in the wire. This is Abe Lincoln, the subject of the watermark for the $5 bill.
The wire mesh is wrapped into the shape of a cylinder that then rotates partially submerged in a tank. The tank holds the paper, now liquefied into a slurry of 96% water. As the wire mesh turns, the pattern of the watermark subtly rearranges the fibers collecting on its surface.
The mesh of the wire is so small that it captures the fibers. So as the fibers are draining, they accumulate in the low areas, they're sloughed off in the raised areas, and the resulting sheet of paper has this reduction in opacity where it's thin, increased opacity where it's thick, held up to the light. It produces that multi-tonal shadow look of a watermark.
Like the watermarks, the security threads play a key role in frustrating counterfeiters. These 3-inch wide rolls are 48 threads wide, and each roll contains enough thread for more than 2.5 million notes. Slitting the roll requires surgical precision, as each of the 48 threads is separated by a space only 1/1500th of an inch wide.
So we have to introduce a plastic strip whose thickness is roughly equal to 1/4 of the thickness of the paper, get it right into the middle, right inside the paper on a continuing basis, thousands and thousands and thousands of miles with no defects.
That's one of the secret processes Crane couldn't allow our Modern Marvels crew to capture. After that step, further refinements and drying, the nearly finished paper emerges as a roll 16 bills wide. To ready the sheets for printing at a later time, machines then apply a special coating called sizing.
This is an animal glue and chemicals that seals the surface to this paper because it'd be real porous without it, and the ink would just spread through the fiber. They put this surface sizing on it so it prints well.
After the coated paper dries, cutting machines complete the paper's long odyssey, dividing the rolls into sheets bearing the templates of 32 bills. What began as raw cotton is now the world's most durable banknote paper, and a counterfeiter's worst nightmare.
What makes banknote paper really different is to look at it in transmitted light. This is where the primary security features are revealed. We have the watermark of Abe Lincoln in every note, and we have the security thread. And the security thread has the denomination of the note. In this case, it says USA 5. So in transmitted light, these are visible. In reflected light, they're gone. It's a tough assignment for the counterfeiter to produce a feature that fills that bill.
Echoing Tim Crane's analogy, the pizza crust of the banknote is ready for delivery. It'll be up to the Bureau of Engraving and Printing to add the all-important toppings. This kind of assembly line efficiency began changing the face of America's money factories early in the 20th century. At the U.S. Mint, productivity had skyrocketed with the advent of electricity and automation. The same was true at the Bureau of Engraving and Printing. Both agencies were helping to energize the economy of a nation emerging as a global power. Each was now filling production orders from the recently established Federal Reserve. In 1913, President Woodrow Wilson had signed the act creating it, hoping to stabilize America's money and banking system. It provided an elastic currency that could expand and contract in response to the economy's changing demands. The Mint and the BEP are the Treasury Department's currency suppliers to the Federal Reserve. The Fed, as it's called, has 12 districts nationwide that monitor America's money supply. When the amount of cash in a district falls below acceptable levels, the Fed places an order with the Mint and the BEP to make and deliver more money. During the Fed's early years, the money it managed finally began to resemble what we take for granted today. Until the 20th century, no likeness of a president had ever graced an American coin, a tradition inspired by George Washington. Washington had rejected the Mint's plans to use his portrait, wanting no part of a practice exercised by European monarchs.
And it really wasn't until the introduction of the Abraham Lincoln penny, in which you saw a president on a coin. Shortly thereafter, you saw other presidents show up on coins as well. You see Thomas Jefferson, and of course we have Franklin Delano Roosevelt, John F. Kennedy on our coins today, and George Washington himself on the quarter.
America's paper currency also got a 20th century facelift. Until 1929, federal banknotes were a half-inch wider and nearly an inch and a half longer than today's. Designing a smaller note enabled more notes to be printed for every turn of the press. The dimensions of our bills haven't changed in 3/4 of a century, but virtually everything else about them has. Making the new generation of currency combines old-school craftsmanship and cutting-edge technology. Some of us might have doubts about how wisely the American government spends money, but you can be certain it's well equipped to create it. The Bureau of Engraving and Printing's facilities in Washington, D.C. and Fort Worth, Texas, churn out 35 million banknotes every day, with a face value of about $635 million.
We have to produce billions and billions and billions of this product. It has to be easily recognizable. It has to be consistent billions and billions of times, but it also has to be exceedingly difficult for someone else to produce. Now that, to me, is a challenge.
The BEP, like its sister agency, the U.S. Mint, relies on an elite staff of engravers to craft its master dies.
The art of engraving itself hasn't changed much. The tools are very similar to what they were 400 years ago. The primary engraving tool is a burin or graver. It's just it's a straight steel shaft that's polished on two sides with a bevel on the end of it. And you just put it in a small holder and push with the palm of your hand through the metal, and it cuts a tiny little curl out at a time. You can control the depth and width of the line with astonishing accuracy.
And you're doing this pretty much in miniature version, and you're doing this backwards and reverse. And the fascinating thing is, if you make a big mistake, 9 months of work will go down the drain in just one cut.
Making a mistake in original die is a tragedy. I would have to fix that by using a scraper. I would have to hollow it out in that area until I made a smooth little depression. Then take the engraving die, flip it over, hammer the back of it so that it would raise a bump on the surface. I would then take a series of little honing stones over the top of the surface and smooth it back and forth until it was absolutely flat. Then take burnishing tools to repolish the area, then mark it back in and recut it accurately. You end up destroying a good deal of work around the error.
Once completed successfully, however, a skilled engraver's handiwork is a banknote's first line of defense against counterfeiters.
If I were to ask any one of my banknote engravers to engrave the very same design, exactly the same, twice, that person can't do it because of the subtle human nature of designing. The human aspect of engraving a banknote is unique to that individual process and that unique to that time. That exacting, detailed 19th century craftsmanship is the cornerstone of how we build our counterfeiting deterrent strategy.
The uniquely etched master dies are duplicated in plastic to craft the intaglio press's 32-sheet plates.
They're welded together in individual rows, 8-door row. One row is welded, they're inspected again, checked to make sure it's the right size, and then it goes to the second row, and we do that, so we'll end up with 4 of these rows. And then it comes time to put it together. Then it's one long weld, and we put all 4 of them together, and you can see on the back, you can see where it's welded. Each one was welded individually first, and then welded 3 times across to make 4 rows.
After a plate maker coats the plastic plates in chromium, the engravers inspect them. Then the plates are secured to the presses. But we're not quite ready to fire them up. Before the intaglio printing begins, some denominations of the blank 32 subject sheets are offset printed. The process adds subtle colors, symbols of freedom, and microprinting, forming a new layer of complexity to foil counterfeiters. Let's take a look inside the massive printer that applies the offset hues and images. The simultan press.
The ink is applied from the rollers onto the plates. The image is then transferred to the blanket cylinder. The paper comes between the 2 blanket cylinders, being the face and back, printing both sides simultaneously. This is the feeder end of the simultan press. This is where we put our offset images on it. The paper is fed down the elongated feed board, down into the pre-front lays, and this is where it actually goes into the printing units to print both sides at the same time.
We're running the orange ink, the green ink, and the blue ink, and right now I'm about to put the green ink in the inkwell. We refill the ink fountains approximately every 4 hours, which is the equivalent of about 30,000 printed sheets.
During offset printing, vigilant pressmen keep a close eye on quality.
We will extract the sheet during the running of the press and bring them over to the AutoSmart scanner and read all the color swatches for ink density. He's looking at the orange and the green, and he also reviews his blue. We have to monitor that very closely. Our tolerance and standards for our currency production is very, very tight, so we have to monitor it constantly.
Precision and attention to detail are equally vital during the intaglio printing. An old process with a new look.
The concept of intaglio printing remains the same. It's just that we take advantage of modern technology to deliver that concept in a quicker, faster, more economical way.
The intaglio presses can print as many as 10,000 of the 32 note sheets every hour, but only one side at a time. They churn out the reverse sides first.
This is the sheet that has been removed from the back intaglio press, and the pressman will examine the sheet for various flaws that occur during the process. They'll examine all sides, even both the side that's unprinted and also the printed side.
The printed sheets are set aside to air dry for 3 days. Then the front sides are printed. After another 3 days of drying, the paper is cut in half into 16 note sheets. Then, during a process called overprinting, a letterpress adds 3 crucial final touches.
These are the sheets that are coming out of the delivery of the currency overprinting machine. They now have the serial numbers on them, the unique Federal Reserve seal, and also the Treasury seal.
Next, the now fully printed sheets are cut into 2 note units, and then into single bills. All that's left is to band 100 notes together at a time. Have an examiner give them a quick once-over, and bundle them together for shipment to the Fed. As the Bureau of Engraving and Printing continues to write the book on creating money, another facility has become just as adept at destroying it. If you like the new look of American currency over the past several years, don't get too used to it. To stay a step ahead of the counterfeiters, government officials have decided that the Bureau of Engraving and Printing will produce a redesigned banknote every 7 to 10 years. But no matter how often and how much we change our money, it'll never be safe from the copycats.
There is no such thing as a counterfeit-proof note. The reality is, with enough time, resources, effort, you can duplicate or simulate any document.
The technology available through consumer products, through desktop printers, through software, has brought the counterfeiter toolkit to a level of sophistication that just didn't exist 15 years ago.
All you need is a finger. One finger, you push a button on a color copier, and you've got a simulated counterfeit note.
Since 1865, the United States Secret Service has sought out counterfeit cash and arrested offenders. In recent years, its agents have confronted a bold new threat: counterfeit $100 bills of such high quality that they're called super notes. Investigators determined that the super notes are printed on cotton fiber paper, using the same kind of intaglio presses operating at the BEP. The bills were finally traced to a government-financed facility in North Korea.
Super notes elevated the level of counterfeiting beyond the reach of anything those of us in the business of anti-counterfeit technology thought we'd have to confront: state-sponsored counterfeiting.
If a counterfeiter has state resources, that's difficult. There isn't anything that we believe we can do
from a design perspective to address state resources.
The American government hopes to shut down the North Korean operation through diplomacy and international law enforcement. Most Americans could never tell the difference between a supernote and the real thing. But the fakes are spotted with relative ease at the 12 branches of the Federal Reserve Bank. Authentic currency contains covert features that supernotes lack, and the Fed's high-speed processing equipment automatically detects the difference. It's all part of the Federal Reserve's duty to manage the flood of newly printed and circulating currency shipped to its branches. The New York branch processes over 13 million notes every day. All the while, its shredders do the dirty work, destroying 4 million unfit bills daily. The shreds hurtle to a disposal area, where they're compressed into small blocks. Some experts believe we'll someday be able to trash all our currency, as electronic alternatives offer the promise of a cashless society.
Today you see much more readily the acceptance of credit cards and debit cards for low-value transactions. Toll booths, laundromats. Most retail outlets now are eager for you to use your credit card or debit card in lieu of cash.
And if you look at transactions increasingly, there are points where paper money is actually a burden, but there are transactions that require anonymity. And as long as there's a need for anonymity, there will be a need for banknotes.
If currency and coins stand the test of time, it won't be just because we want to avoid leaving an electronic signature. Our money expresses our national identity and our cultural character.
Coins will always be around in large measure because they represent something very important about a country. The important values of our nation, in God we trust, unity,